You build a RAG app. A user asks, "What is the refund policy for annual plans?" Your vector search returns 5 results. The pricing page is number 1. The actual refund policy, buried at number 4. The embeddings are close, but close is not the same as correct. Vector similarity measures distance in embedding space. It does not measure whether a document actually answers the question. This is the gap that kills RAG apps in production. The results look relevant, the scores are high, but the best answer is not on top. To understand the fix, you need to understand the problem. Most RAG systems use Bi-Encoders for retrieval. A Bi-Encoder processes the query and each document separately. The query goes through one encoder. Each document goes through the same encoder independently. Both come out as vectors. Then you compare them with cosine similarity. This is fast. You can pre-compute all your document embeddings once and store them. When a query comes in, you encode it and compare against everything in milliseconds. The trade-off? The encoder never sees the query and document together. It cannot reason about how they relate. It just compares 2 points in space. That is why a pricing page about annual plans scores high for a question about refund policy for annual plans. The words overlap. A cross-encoder takes a completely different approach. Instead of encoding the query and document separately, it reads them together as one input. The query and document get concatenated. They go through a single transformer as one sequence. The model sees every word in the query next to every word in the document. It can reason about their relationship directly. The output is a single relevance score, not a vector distance, but a direct prediction. How relevant is this document to this question? This is much more accurate. The cross-encoder understands that refund policy for annual plans is asking about refunds, not pricing, even though both documents mention annual plans. But it is slow. You cannot pre-compute anything. Every query document pair requires a full forward pass through the model. Here is the technique that fixes this. Cross-encoder re-ranking. It combines the speed of Bi-Encoders with the accuracy of cross-encoders in a 2-stage pipeline. Stage 1. Your Bi-Encoder retrieves the top 20 candidates. This is fast. Milliseconds. You get a rough set of potentially relevant documents. Stage 2. The cross-encoder re-ranks those 20 candidates. It reads each one paired with the original query. Now it can reason about actual relevance. 20 forward passes instead of searching your entire database. The results change dramatically. Watch the refund policy example. Before re-ranking, the pricing page sits at number 1 with a similarity score of 0.72. The refund policy is stuck at number 4 with 0.58. After the cross-encoder re-ranks, the refund policy jumps to number 1 with a relevance score of 0.94. The pricing page drops to number 4 with 0.31. Same documents, same query, completely different ordering. The cross-encoder understood what the user was actually asking for. If you want to learn how to do this yourself, I run free live sessions every Friday at noon Eastern. Scan the QR code on screen to join. Would love to see you there. Why not just use cross-encoders for everything? Math. If you have 100,000 documents and use a cross-encoder for each one, that is 100,000 forward passes per query. At 50 milliseconds each, that is 83 minutes per search. Completely unusable. A Bi-Encoder? It pre-computes all document embeddings once. At query time, you encode the query and do a vector comparison. The entire search takes under 100 milliseconds. Re-ranking is the middle ground. Bi-Encoder narrows 100,000 documents to 20 in milliseconds. Cross-Encoder re-ranks 20 documents in about 1 second. Total latency just over 1 second. That is the sweet spot. You get 95% of the accuracy of a full cross-encoder search at a fraction of the cost. You do not have to build a cross-encoder from scratch. Cohere Re-Rank is the most popular hosted option. You send your query and a list of documents. It returns them reordered by relevance with scores. 3 lines of code. Gina Re-Ranker is another option, open source friendly. Voyage AI focuses on domain-specific re-ranking. And if you want to self-host, the cross-encoder models on Hugging Face work well. The MS Marco models are the standard starting point. Pick the one that fits your stack. The concept is the same across all of them. Retrieve broadly, then re-rank precisely. Let's zoom out. Without re-ranking, your RAG pipeline looks like this. User asks a question. Bi-Encoder retrieves the closest embeddings. Results go straight to the LLM. The LLM works with whatever it gets, even if the best document is buried at position 4. With re-ranking, you add one step. The cross-encoder reads each candidate paired with the query and reorders them. Now the LLM gets the most relevant documents first. Better context in, better answers out. If your RAG app returns technically correct but not quite right answers, re-ranking is probably the fix. Retrieve broadly, re-rank precisely. That's how you find the right result. That's the full picture. If you want to go deeper, join my free live session this Friday at noon Eastern on Maven. I walk through this hands-on, answer questions, and show you how to build it yourself. Scan the QR code to join.